We are going to be working with arrays. And arrays are like little tables. Most of the time, you're going to be working with a one column in multiple rows. And that's called a one-dimensional array. I did go through an example so that you could see how to work with a two-dimensional array. But most of the arrays you're going to be doing for me in this class are going to be one-dimensional. And basically, all an array does is it lets you store multiple values under a single name and a single data type. So you've got one data type and you can store multiple values. Okay. And so how you create one of these is you give it the data type, and then you've got brackets, and then you give it a name. Okay. Now, just declaring it like this doesn't actually create the object that goes in memory. It's kind of like you're intending to create it. So it's like an intention letter kind of thing. Okay. It's not actually created yet. To reserve that space in memory, we have to use the new keyword followed by the data type and actually give it a size. It needs the size in order to know how much space to grab. So here I've got string sentence. And then here is where I am telling it how big it is. So at that point, it can occupy a space in memory. And here I've got double golf score. And here's where I'm saying how big that array is. Okay. And arrays are reference types. So they go in the heap. So you can create arrays in 2 steps, or you can do it in one. I tend to do it in one unless there is a really good reason for me to do it in two, because I just don't like doing a lot of extra typing. So if you want to do it in one step, it's just the string with the brackets or whatever the data type with the brackets, whatever you're going to call your array equals new. And then you've got your data type with the size in brackets. And so it doesn't matter if it's a string, double, integer. You can even do an array of structures using this same convention. Okay. So if it was structures, we are talking about our music structure that we were just looking at, we would need something like music is the data type, and then we would have the little brackets, and then we would have whatever we want to call it equals new, and then we've got music, and then we would have some kind of a size here. Okay, so you can do objects, you can do structures. Okay, arrays are super flexible. Now, when you set the size, what the compiler does is it initializes the array elements to a starting value. So for numbers, the starting value is 0. And for string and characters, it is spaces. A lot of people will initialize an array when they create it. So here we're creating it, we're reserving the space in memory. And the compiler is setting it, if it's a numeric array, it's setting all of those spaces to 0. Well, we could do something like this. We can actually give it a list of the numbers that we want to store. And this is called an initializer list. Okay. And then instead of putting all zeros in there, it's actually going to put the numbers that we want. So when you create the array, if you know what you want to store, you can certainly create an initializer list and put those values in there. Okay, and so these are just examples of numeric arrays. And then you can see here is one with strings. And now this one with strings, you'll notice I didn't give it a size. Okay, And if you don't give it a size, then it uses that initializer list to figure out how big it is. So I got 8 items in the list. So favorite foods is an array of 8. Okay. And up here, I did the same thing. I've got 5 numbers. So ARR is an integer array of 5. Now, once you've got values in the array, you can retrieve them by indexing in. And the very first index number is 0. It always starts indexing at 0. Okay, and that's the lower bound. And then the upper bound is going to be the length of the array minus 1. And that's because it starts at 0. So, I mean, if you counted, you would count 9. But the last index number that you would use is an 8. So it's the length minus 1. If you want to access any value in an array, it is simply the array name, and then in brackets, it is the element that you want to access. So you give it the index number. So if this array was called ARR, okay, and we have ARR2, it would be changing the value 6 because that's what is currently stored. Okay, and so here I've got a string called favorite colors. It's a string array. And in the first position, I change it to orange. Then index 1, I change to green. Index 2 is yellow. And the rest don't have anything in it. You will quite often see for loops handling arrays because they have the ability for you to use an index. That is why a lot of them say int I equals 0 because I is for index. And then the condition it'll check is I less than the length of the array. And then each time you loop through, you add 1 to the index or I. Okay, that's very typical array processing. So here is another little example. So here I did not give it a specific size. So it's going to take on the size of the number of items that I initialized to. And you can actually write that number out. You can take the name of the array dot length, and you can use that number. You can use it in a for loop. You can print it out. And typically that number is used in a for loop. And there's 2 loops that are used in arrays, for loops and for each. And the difference is a for loop, you are going to be indexing in, and with a for each, you do not index. It automatically goes through every single item in the array. So here's an example with the for loop. And you can see that I didn't set the size, I just initialized it. And so I've used favorite food.length in my condition that it's checking, and I'm just printing out each item in the list. Here's another example. I've got golf scores, and you can see it's an integer array, and I made it 20. Okay, and so I've got something I'm calling temporary score. And then I've got a little loop here where I'm going to be filling in my array. And I'm not going to force them to enter 20. So I'm going to pretty much let them enter as many as they want, as long as they don't exceed the length. So the condition that's being checked here is that the index has to be less than the length. And then and the length is going to be 20. And then the temp score, which is like a little flag, cannot be -1, because if it's -1, that means the person entering the data wanted to get out. Okay, so the console is going to say, please enter your score -1 to end. So we're reading in that score. And as long as it's not -1, we are adding the score to the array. If it is -1, then it's going to catch it up here and we're going to get out of our loop. Okay, and then you can see I've got a total, average, and a score count. And I can't assume that they've entered all 20. Okay, so I have a little loop and it's going to go through 20 times, but I'm going to check the score to make sure it's greater than 0. If it's greater than 0, I'm going to add it to the total, add 1 to the score count. Okay, and then I can do my average when I'm done. Now, for each loops, they are actually designed to work with arrays. And so the way that they work is you use the keyword for each. You have to tell it the data type of the array. And then you're going to give it an alias. So whatever you call it here, that is what you are going to refer to each element as. So it's automatically going to go through the array and pull the value for each element. And this is what you're calling it. Okay, and then you have to use the keyword in, followed by the name of your array. So this is your little alias here. So inside this loop, S is the value that is being stored at the element it is processing. So here again, I'm going to check to see if it's greater than 0, adding to the total, adding to the score count. So this little for each loop could be used in place of this one. Okay, and you can see it is a little bit cleaner because it automatically is going to go through the entire array. So I don't really have to have a counter or anything like that. So here is how that would look in an example. Okay, and anytime you know you're going to process everything, you can use a for each. Now, I wouldn't use a for each up here when I'm adding the data because I'm allowing them to exit out, right? If they only want to enter 5 scores, they can just put in a -1 and then they're out. But down here, I do want to look at everything. So I put them into a for each. Now, when we pass arrays to methods, it's very similar to passing other variables, but in the method header, you do need to include the brackets, and you also need to remember that arrays are reference variables. So you are actually passing the data in the array itself. So if you change anything in that array, you don't need to return it. You're changing the real thing. So it's not making a change to a copy. So here's a example. And let's see. This one is called Feed Me, my namespace. How many items would you like to enter? We've got the size. And we are using that size variable to create our string array. And then we're calling fill string. And we're passing it the string array. So come down to here into fill string, and you can see that I've got groceries on my list here. So we are going down to fill string with the array, and you can see how we're pulling it in. And while we're in this little method, we are going to refer to that array as ARR. And you can see we've got our little for loop here. Enter the item, and then we read it in and put it into the array. Very nice and clean. We don't have to return the array because it is changing the real thing. So even though we're calling it ARR here, okay, we got past the string array. That is what is being changed. Okay, and then we've got print string. going to come down here. Again, we're calling it ARR, but it is the same thing. It is this string array. And then we're just going to go through it and print everything out. And so here's my little list. Buy groceries, prep food, prepare dinner. Sounds like what I need to do when I'm done with this video. Moving on to program number 2. So we've got a couple different methods in here. So this one is for money. What is your beginning balance? We're going to read that in. How many checks would you like to enter? So here comes our array. Here's the size. And so we're making a double array. We're calling it money ARR, new double size. And then we've got print balance, where we're passing it the balance. And we've got enter checks, where we're passing it our money array. So print balance, it shows the current balance basically. Okay, that's all it's doing. And then it's checking to make sure that it's not less than 0. And then when we go into enter checks, while we are in the enter checks method, we're going to call the array my checks. So money array and my checks are the same thing. Okay. While we're in here, it's going to loop through my checks, and it says please enter the amount, and then we fill that in to the array. So my checks is the same as the money array. We do not need to return anything here. Okay, because when we make changes to my checks, it is changing the money array. Okay, and then our next statement, calc new balance, we're going to pass it the balance and the money array. So we come down in here, and we're pulling in the balance, and we're pulling in the money array. And so then you can see that we've got a little for each, and we're going through our little money array, and we're totaling up our checks. And then we are printing out our total, and then we're returning the balance, which is the balance minus the total checks. So we're calculating the total, printing it out, and then we're returning that balance less all of the checks we wrote. Okay, and then down here, we're going to print the balance again because it's changed. So we come down here and again, printing out the current balance and checking to make sure that we have funds. Now, one little cool thing that may be new for a lot of you, and I've not seen this in other languages, is creating a subset. So in C#, if you have an array, you can create a new array from a subset of the original one. And all you have to do is, use the variable keyword, give it a name, set it equal to the array, give it a starting index, ... and an ending index. Okay, so this kind of illustrates how that will work. So I generated some random numbers, which you can see here. Okay, and so I said to start at the index of 1 and end at 4. So remember, the first one has an index of 0. So here's 1, 2, and 3, and it did not include 4. And so here I've got 1, 2, and 3. So we got 0, 1, 2, 3. That's what it included in the subset. And that brings me to multidimensional arrays. Now, when I was in programming, I actually did have to work with these. And so the way that how my head works is I jot down on paper what this table is going to look like, because a multi-dimensional array is a table. And so I kind of fill out my columns and I look at, what I want it to do, because then for me, it's easier to program it. So here is an example. We've got sales rep numbers that we're going to use to index in. And then we've got different sales quarters with figures. And then we have a grand total that we could fill in. Okay. And so that's kind of what the data looks like. And the syntax for a multi-dimensional array is whatever your data type is. And then you've got a comma. Now this is for, your rows and your columns. I mean, you can have three-dimensional arrays. You can have two-dimensional arrays. If it's a three-dimensional array, you have to have two commas. I have never created a three-dimensional, to be honest. I've done two-dimensionals quite a few times, but not three. But anyway, you've got to give it an array name. And then, so that kind of is your intention to create the array. To actually reserve the space, then you have to kind of spell it out. So you've got your data type, brackets with your comma, you've got your array name equals new data type, and then you have to give it the number of rows and columns. And when you give it the number of rows and columns, that is when it takes that chunk of memory. So in this little example, I'd probably call it sales, and I'd use double. So we've got double, and then I've got the comma, sales equal new double. And I got 5 and 10. So 5 is rows, although I've got more than 5 rows. We're going to pretend there's only 5. And then we've got 10 for our columns. Okay, I do have this all coded out so you'll be able to see it. Because an array is a reference type, the compiler is automatically going to initialize everything to zeros, which is kind of good, and especially in a larger table. The tough thing about a multidimensional array is that you've actually got two different values that you're indexing in with. And so for me, especially when I'm teaching this, I honestly like to use the words rows and columns because then it's easier for you guys to visualize what's going on, right? We got rows, we got columns, okay? So in this little programming example, you can see I made the rows and the columns constant. Okay, and the rows are going to be reps 0 through 100, and then we've got 5 columns. Okay, and so I did that above the main method, so everybody knows about these values. And then you can see in the main method, I create my little sales, a multi-dimensional array, and then I've got a menu I display. So this menu is not very complex. They can add, or they can print, or they can quit. Those are their choices. And so, if they don't enter a 1, 2, or a 3, this is going to keep them in this bad data loop. Okay. Actually, if they don't enter an integer, I'll qualify that, because they could enter a 10 and it'll work. But if they enter text or anything that's not an integer, then it gets them into a loop. So what they're returning here is an integer. Okay. So they're returning that integer up here. And as long as it's not a 3, then we get into a switch. So the switch is where we're going to catch, a bogus number. So if it's a 1, they're going to add. If it's a 2, they're going to print. And if it's anything else, well, they made a mistake. They made a bad selection and they need to try it again. Okay, and then you can see we've got the menu down here. So the two methods that will be called are print and add. You can see in the add method, I did add try and catch. which rep are you adding sales for? So we're reading that rep number in. Which quarter are you adding sales for? We read that in. And because our index starts at 0, we have to subtract 1 here. And we don't have to do that for the rep. We're just going to go directly. The row number is the rep number. Okay, but for quarters, we are starting at 0. So then we want to enter the sales amount. And so we've got the rep and the quarter. That is how we are going into the table. Okay, and then we've got, if they've got, bad data, we've got index out of range. So it is possible in this little scenario that, they enter rep 500 who exists beyond the bounds of our table. That would trigger. Format exception. So we're asking for an integer and they type text or something. They're not a good typist. So it'll catch that. And then exception down here catches anything else. Okay, so that's our add. The print is pretty straightforward because we've got a little title that prints out. And then for me, in my head, I mean, you can process by columns and within columns do rows, or you can do rows and within rows do columns. So I process by rows. So basically what it'll do is it goes row by row. Okay, and then it goes and it looks at each column that's in the row. So it goes to the first row, the second row. Okay, it goes through all the rows, and when it's on each row, it zips through the columns. Okay, so you always are going to have a double for loop in a multi-dimensional array. So here I've got R stands for row, and you can see here's my outer loop, and then the inner loop where I am now going through each column. And so basically, I am probably not going to have everything filled in. If I had slots for 100 reps or 1,000 reps, and maybe I only had quarters 1 and 2 of data, I don't have 1,000 reps. Okay, let's say I have 100, but I have slots for 1,000. I got a lot of zeros. So here I'm only going to print if there's a value greater than 0. So it's going in. Let's say it gets down to row 20 and it's going in. Yep, that is bigger than 0. So I'm going to print it. That's bigger than 0. But what about row 21? Well, there is no data in row 21, but remember the compiler initializes to 0. So that means that, yeah, there's a bunch of zeros there. So I don't need to see row 21 because there is no rep. And so I only want to see the rows that have data in them. And so that is what it's doing. It's checking to make sure that in that little cell, there is data. Okay, and then it prints it out. So if you want to see this run, you can. I mean, you can fill it in, you can copy the whole thing, you can paste it, and it will run. And let me pull this over. So if you decide to do this, make sure you do a build so that you can ensure that you got all the code, and then you can run it. So we'll do an add. I'm going to add for rep 50 to quarter 1. And then if I do a print all, okay, this is why we check for 0, because otherwise I would have just had a gazillion zeros. But you can kind of see how it works. Now I could add another one for rep 50 or add a different rep, okay? Or I can just quit. But if you guys want to play with that, you can. And I do have a sample run here. And that is pretty much it for using arrays.